Hello everybody. This is going to be part 2 of my capacitor decade box, and I've got quite a story to tell. This is what the finished product looks like. I'm going to walk you through the front panel, what it does, how it's supposed to be used, and then I'll take the top off and show you what it looks like inside. So a couple of things that you'll notice differently from the first video is that I removed the 70 microfarad 350 volt cap. And the reason why I did that is I have a whole bunch of 500 volt caps in here. There'd be no reason to put a 350 in there. That would defeat the purpose. And quite honestly, the way I had it wired originally, if I put something over 350 in any one of these, this would have popped. And I'll explain what that happens later, why that happens. I had a switch here originally to drain the caps. I no longer have that. I have this banana lead coming out right here. And the reason why I had to do that is in order to get this this meter to work, I would have to connect it to every one of the positives, and by doing that I would basically be multiplying the capacitance. I could put a switch in there and put a switch for each value, and a 10 position switch. When that kind of defeats the purpose. I'd have to put a fairly beefy switch in there too, because this 500 volts DC is nothing to play with. So the way I have this designed, let's assume for a moment that I'm gonna require a 47 microfarad cap. What I would do is put this in here. That would activate the meter, and then I would put my lead, my other banana clip lead, right in here, and that would go back out to the amp or to the radio. And this way I activate that meter depending on which cap I'm going to use. As soon as I remove the power, I can watch the needle drain. And we'll talk about the bleed resistor story as well. So that's how that works. And if I wanted to measure multiple things, I could always daisy chain these things. I wouldn't do that though. So 47, 22, 80, 30, 8, 10, and here's a 100. And it always goes in the positive side. Let me open up the top. I want to explain to you some of the things that I learned while I did this. And one other thing before I go there, all these negatives are still connected to each other. So there's really just one common negative here. Essentially what that means is that in order for me to use this in a radio or an amp, all of the capacitors have to have a common negative side. If I have a capacitor that has a negative side in one place and another one that has a negative side in another place, I couldn't use this configuration, because it would basically be a problem. It wouldn't be good. I could probably short out something or blow the transformer or whatever the situation is. So that's, in this particular design, I have these things common. I may at some point rip all this out and redo it, and maybe I'll make individual connections. We'll see. So let me power this camera down for a second, take this top off, and I'll show you what we've got inside. Be right back. Okay, so we're back on the inside here, and the first thing you'll notice is I got rid of that that second layer of resistors that I had here, and you'll notice that I have these resistors independently soldered to the caps. So every cap has its own bleed resistor, and I learned quite a bit about bleed resistors on this build. And I learned, I didn't know, that there's a calculation that you need to follow. So it's based on the number of the amount of voltage that you're putting through the cap, and it's based on the resistance. And based on that calculation, it determines the drain time. So for example, in doing that calculation at 500 volts, and let's say, let's pick something that's easy. Here's an 8 microfarad cap here, electrolytic cap. So using the calculation with 500 volts, with a 250K bleed resistor, it will take approximately 2 seconds to drain that cap. Similarly, if I talk about this 100 microfarad cap right here, it'll probably take about 25 seconds to drain the cap using the calculation. And so on and so forth. So you talk about 30, it's going to be, somewhere, probably, let's see, 3 times 2, probably about 7 or 8 seconds here. And then 80, you're talking about probably 16 seconds or so. I'm kind of just doing mental math here. But that's the ticket. So on this particular build, I didn't have 250K resistors. I had 220K. So I've used 220K here. So it's going to take a little bit longer for these to drain, but that's okay. I do have that meter in the front that I can connect and watch it. On this particular 100 microfarad cap, I did use something a little bigger. I used the 270. So that will probably come down and probably drain in about 20 seconds or so. So in theory, I have these caps isolated from a positive perspective, which is why I need to use that wire on the front for the meter. I do have the negatives still routed together on the bottom of this board. Okay, so that's an important distinction. I've got everything else relatively neat in here. I've got all of my wires connected. I'll turn this around and show you what that looks like. And I'm going to need to go in and clean this up. But that's what this prototype looks like. Let me turn the box around and show you the other side. Right back. Okay, so here's the back of the control panel. Okay, and here's our DC meter. And you'll see that I've got one side of the DC meter connected to that yellow jumper wire that comes out the front, and the other side of the meter connects to this common ground. That's why that yellow wire in the front goes into the positive. So I'm basically just going across the cap. I've got everything labeled on the inside. So this is a 47, the 322s, the 10, the 8, the 30, the 80, and the 100 over here. So I have everything there. I have this terminal strip which I need to remove. I didn't need it. I thought I was going to need that. And I've got everything in here neatly. I'm going to wrap these wires and get them a little more neat. But this will serve the purpose. Now, some of you said in the comments, well, it's nice that you're doing this, but I don't understand why you're doing it. I don't see the use for it. So I can give you one use case which is valuable for me. As you know, I work on amplifiers, and the Fender Bassman amplifiers are the ones that I typically try to work on. And when you take that resistor pan off the top of those things, tucked underneath there's usually an 80 and 320s that are connected all to the same ground points. So theoretically for me, if I was working on one of those and wanted to do a quick test, I could use this box and connect everything up and use the capacitors on this board to do that test. Again, I have to make sure that they all have common negative sides, and that they're not independent, but that's okay. As long as they're all common, I'm okay. For an antique radio, I probably would use just a single resistor capacitor on this thing. I would probably use the 8, which is common, filter caps, or the 10s. Sometimes they have a 4 in there, but I can use the 8 for testing purposes. So that's why I put in the 322s and the 70 and the 80 and the 100, because that's going to be the most common for an amplifier. Other values that I put in there, like the 47s sometimes you see in the antique radios, so I've got that in there. And this is just going to be one tool that I'll use that'll help me when I need it. And plus it was fun to build a project from scratch. So with that, I'm going to flip this around one more time. I want to just walk through the front panel with you, and we'll take it from there. But before I do that, I just want to show you what I've got on the back here. Danger, high voltage, discharge caps before opening. This way the next guy that gets this doesn't kill himself. Let me flip it around. Okay, just zeroing in on some of the warnings. Caution, always observe polarity. Connect to plus side of the cap for the meter. I've got my little name in the box there, and of course I have each connector labeled plus and minus, and that's where we are. There's my meter. I could show you one more thing before we wrap it up, just to prove that my capacitors are actually working well now. Again, when I had the 100 ohm resistors in this thing, I was getting really weird capacitance readings. For example, if I was measuring capacitance on the 8 microfarad cap, I was getting 16. It was doubling. I couldn't figure out why. Then I learned all about that calculation. Let me show you one thing, and then we'll be done. Be right back. Okay, what we have here is a capacitor checker. And what I'm going to do on this is I'm going to put this on negative lead. It doesn't matter which one, because they're all common. I'm going to measure each cap and show you what it does. Let's see if you can see that. There's the 47. It's right in the ballpark. There's the next one. 48. Here's a 22. Right on the money. Good. Good. Here's the 10. Here's the 8. Here's the 30. Here's the 80. And here's the 100. Okay? So when I was doing this test before, when I had all those resistors wired together, I again was getting really weird readings. So a few people I need to thank here. I need to thank Carl, Sky Carl. I need to thank JP, who was invaluable in helping me to get my head on straight around this project. He warned me, you've got 500 volts in there. You could have fireworks if you have the wrong resistors in there. By the way, that calculation I was telling you about also calculates the wattage that you need. The way that I calculated this out is I would need 1 watt resistors. I'm using 2 watt resistors inside. So I want to thank JP for his help. And then everybody else who's commented on this, and I always appreciate your support. This is a great way for me to learn about bleed resistors. I now know a lot more, and a great way for me to build a little project that I can use in my little arsenal of tools. So we're going to wrap this up for now. I'm going to button that up after I do some tie wrapping, and we've got ourselves a nice little test set. Thanks for all your help, everybody. I really appreciate it. That's the best part about this community, is we help each other. Have a great afternoon, folks. Thank you.